In order to determine the power through each element, what I first did is I labeled each element. I gave it a name. Because I'm solving for power, I chose P. And because I have multiple elements, I just use subscripts. So this guy here, I labeled it P sub 1 all the way to P sub 6. Now we're going to be using the power formula, and the power formula is, or one form of the power formula is P equals IV, where I is current and V is voltage. In this particular problem here, they told us that the current through each element, well, the current through each element is given. We have different values for some of them. And then also they gave us the voltage of each element. So that's very helpful because that means we can just plug and chug into the formula. Now P sub 6 is going to be a little bit different because this guy is in terms of I naught, but that's okay because they gave us I naught. They told us that I naught is 2 amps, and they also told us that V naught is 18 amps. So that's going to help us find this guy here, and the I naught is going to help us find the power for this guy here. Now, before I go into explaining how I came up with the values that I got for the power through each element, it's important to understand the passive sign convention for power. One of the formulas for power is current times voltage. Now, power is going to have two signs associated with it. It's either going to be positive or it could be negative. Which one we're going to get will be determined by the direction of the current. In the case where the power is positive, that means that the current has to be flowing from positive to negative. Now, if the current is going from positive to negative, then that means that the sign for the power formula is going to be positive. Now, when power is positive, the element is going to be consuming, absorbing, or dissipating power. All these words mean the same thing. Now, in the case where power is negative, that means that the current is flowing in the opposite direction. The current is going from the negative to the positive, which means that power would have to be negative. So if power is negative, then that means that the element will be supplying or delivering power. These two words mean the exact same thing. So with that idea, I was able to move on into actually doing this problem. So for P sub 1, if we take a look at P sub 1, what is going on here? We need to come up with a sign for power for this first element. Now, how we come up with the sign is going to be dependent on what way the current is going. In this case, the current is starting here and it's going to end up here. So because it starts at the negative end and then it goes to the positive end, that means that the power, the sign for this particular power here will be negative. Now, the current for P sub 1, again, it's flowing from negative to positive, so the power formula for P sub 1 is going to have a negative sign. And then from there, we just fill in the values. We know current is 6 amps, voltage is 30 volts, and then we multiply those guys together. We come out with a negative 180 watts. This overall sign right here is the overall power sign. Now, because the overall sign of the power is negative, that means power is negative, which tells us that this element is supplying power. Now, for P sub 2, what's going on in the picture is that current is actually traveling in the opposite direction from P sub 1. For P sub 2, this guy, the current is traveling from the positive terminal and then going to the negative terminal. So if we look at P sub 2, it's 6 amps is first hitting the positive terminal and then the negative terminal. That's what this right here says. So because it's this case here, that means that power is positive. So we just fill in the values they give us, and the overall power is positive 72 watts. Again, power is positive, which means it's absorbing power. P sub 3, same idea. Current is flowing from the positive to the negative. If we look at P sub 3 here, current is 3 amps. First, it's touching the positive and then the negative. That's what I'm saying here, is touching the positive and then the negative, which means that power is going to be positive, and then I fill in the values. In this case, they told us that V is V sub naught, but we know V sub naught. They told us it was 18, so I got positive 54 watts. Again, power is positive, so that means it's absorbing power. P sub 4, same thing. Current is flowing from the positive terminal to the negative terminal. For me, P sub 4 is this guy here. So the 1 amp is first going to touch the positive terminal and then the negative terminal, which tells us that P sub 4 has to be positive for the power. So that's where that guy came from. And then I get positive 28 watts. Again, power is positive, therefore I have to be absorbing power. P sub 5, same idea. Current is flowing from the positive to the negative, so I get a positive sign here, but we can take a look at P sub 5 over here. So we see the current is traveling from the positive to the negative. That's what I'm seeing here. Current is going from positive to negative, so that's where that sign comes from. I fill in what they told me, and then I got, again, 56 watts, which is absorbing. P sub 6 was a little bit different, but again, same idea. The current is flowing from the negative to the positive terminal. So if we look at P sub 6 really quickly, the current is down here, which means that it already came out. But where did it come in? It had to have come in from up here. So then it touched the negative terminal, and then it touched the positive terminal. Because it touched the negative terminal first, it's going to have a negative power, or a negative sign associated with the power. So that's all I'm saying right here, that the current first is going to go through the negative and then the positive, which means that the sign attached to the power for P sub 6 has to be a negative. And then we fill in what they tell us. We know the current is 3 amps. Now the voltage is going to be in terms of I sub naught. I sub naught, remember, they told us was 2 amps. So if we multiply 5 times 2, we get 10 volts, times the 3 amps, we get 30 watts. And again, power is negative because the current is traveling from negative to positive, so it has to be negative. And then the overall power is negative, which means that this guy is supplying power. And then what I did to check my work was I just used the fact that the sum of the powers has to be 0. So I just added up all my powers, and I got it to be exactly 0. So that's my work. Thanks.